which bidders options have been chosen. A1 in category these are category 1 category. So let me do a little bit of erasing. In category 1, how many who have been chosen? In category 2, who have been chosen? In category 3, who have been chosen? And based on that, I also know how much is my R1 in category 1, how much is my R2 in category 2, and how much is my R3 in category 3. So revenue category wise.
So do we need to maintain revenue category wise? We don't need it,
No,
right? I
we
mean,
can
total
calculate,
revenue
we
is
can
sufficient.
calculate, we can calculate, we can calculate. But this revenue category wise, we can calculate. But what will it give you? So this part is those whose bids have been chosen, right? This is those whose bids have been chosen. Sets of elements. Why am I taking revenue category wise? Can you tell me what will it give me?
Density
Gn of
category wise.
Sir, we'll have to check that whether we are which category we are getting more return.
no, total return is our objective.
Okay.
Total
The
return is our
density,
objective.
it will give the density category wise.
No. Firstly, this is our total return, right? That is our objective, is the return. We also have to maintain what? Category wise? Employees, employees selected. E1, E2, E3. Because all this will be required. Obviously, they can be found from these sets. The set 1, set 2, set 3, whose bids have been chosen. From there, you can decipher R1, R2, R3, E1, E2, E3. That is not a problem. These are all derived. The only things which are unique for a state is what? What is unique for a state? These three sets. Who have been chosen and I. That is the unique element for a state. Correct? Is everybody with me?
Yes, sir. So sir, then I don't think we need to apply. We need to put L1, L2, L3 as well.
No,
Because
you
that
don't. That
also.
is, I said, these are all derived entities.
Yes.
The only thing is I and set 1, set 2, set 3.
Yes.
That is all we need for as the independent entities. The rest are all dependent entities.
Sir,
Hmm.
are we assuming that one bidder gives
Hmm.
a like only a unique amount of land requested from one category? Like he can request 500 in one and 300 in the other. Is that possible?
It is possible, but we are, for the time being, I'll come to that issue a little later, Ritavan. For the time being, let us assume this simplistic stuff. The other one has much a more difficult issue to handle. So that is
No,
why.
sir, because if it is not the case, then every bidder will always get only one allocation from a category.
Yes,
So, okay.
that is what we have assumed for now. Later on, when we relax this assumption, it is more complicated. That is why I have not picked it up yet.
Okay, okay.
Sir,
Huh?
sir, as you said, I and the sets are all
Hmm.
those two are
Uh, uh,
independent entities.
hmm.
So while defining a state, these two are mandatory, right? Other can be taken in the state space or cannot be, right?
They are derived entities from the state space, Sharma. Yes. You can explicitly maintain it or you may calculate it every time.
Okay. So I and the state that has to be mentioned.
Yeah, but people normally keep all the others so that they don't have to calculate it every time.
Okay, good.
Everybody with me now?
Sir, these sets comprise of what again?
These sets comprise of, can anybody tell him? What do these states comprise of?
The list of bidders who have been allocated in
So those bidders who have been allocated for category 1, bidders who have been already allocated between 1 to I in category 2, and bidders between 1 to I in category 3.
So we are assuming that one bidder will present only one bid for a particular category.
That is exactly what Ritaban asked
All right.
us 1 minute ago. We are for the time being assume one bidder gives at most one bid per category for the time being. This is an assumption for the time being, just to make sure that we understand what we are doing. Okay? Anybody else has any doubt? Now state transformation rules. From a state S, I will now have how many ways to branch? I will choose bidder. Which bidder I will choose now?
Bidder I.
I plus 1.
I plus 1th bidder. And then how many ways I will branch at most? If bidder has 3 options, 7 ways to branch. At most. If a bidder has less than 3 options, then fewer ways. If a bidder has 1 option, 2 ways to branch. If a bidder has 2 options, 3 ways to branch. If a bidder has given 3 options, 7 ways to branch. Sorry, if a bidder has given 2 options, then 4 ways to branch. So here it is. If bidder has given 1 option, then 2 ways. If a bidder has given 2 options, then 4 ways. If a bidder has given 3 options, then 7 ways. Everybody with me?
Yes, sir.
Okay. Now, what sort of a problem is it? Maximization or minimization?
Maximization.
Maximization problem. So we need HN to be upper bound or lower bound?
Upper bound.
Overestimate.
Yeah, upper bound or overestimate. So what is GN? R1 plus R2 plus R3. Correct? So what is HN?
Revenue density. R1
Yes,
plus R.
revenue density per category. Use category wise compute revenue density. For each category, sort the remaining bids by revenue density. So which means that whatever is RI1 for that, RJ for that bidder by the A A1 J, that means amount requested.
So sir, this we are directly calculating for the I plus 1th bidder, which we are.
All of them. You are calculating for all of them. For every category, you are looking for all the bidders from I plus 1 to N. Okay? So
Yes,
for category 1, you are sorting them by R1 for that bidder, by the area required for that bidder, and you are sorting that.
So
Then
this
for
we
the
are doing for all the bids.
Can you let me complete, please? Everybody has to listen. So we are doing, suppose if we do this sorting, maybe we will, if our I is 4, maybe for category 1, the sorting is B7, B3, B4, B5, B6, B8. For category 2, it may be B6, B7, B5, because they may not have given that category bid. And for the other, it may be B8, B6, B5, and B8. There are 8 people, let us say. I have already chosen up to 4. Now, I sort. In category 1, if I sort by revenue per unit land requirement, I get this. For this, I get this. For this, I get this. Is it now okay? I have sorted. Is everybody with me?
Sir, can you just repeat the thing? Like, I didn't get it.
Till now, I have chosen up to the 4th bidder in this state, right? Having
Yes, sir.
chosen up to the 4th bidder, I have got total of so much of revenue. Okay.
Yes, sir.
And I have got L1, L2, L3 as the remaining land.
Yes, sir.
Now, for category 1, I look at B5, B6, B7, B8, and I sort it by for looking at their bids for category 1, I sort it by their R by A. That means the return by the land requested density.
Okay. Yes.
So now in category 2, because B6 has not given, B8 has not given any bid for category 2, maybe. That is why category 2 is sorted by 3 people. Category 3 has 4 people, 8, 6, 5, and 7 in that order. And category 1 has 5, 7, 6, 8 in that order. Is everybody with me?
Yes, sir.
Now what will I do?
We'll take the sum of the elements such that the area, the left area is covered. I mean, as you discussed in the morning.
Yeah, right. We will take, who is saying this?
Sir, Karthik.
Karthik, yeah. So what I will do is I will take B7 and see if I exceed L1. If I don't, I will take B5. If I exceed L1, then B7 plus B5, the rewards of B7 by B5 is the maximum that I can get in category 1. Is that okay? Suppose I have taken B7 and B7's requirement, suppose L1 is 10. Suppose. And B7's requirement for category 1, B7's requirement is 7 and B5's requirement is 4. So now I will take B7, B4 because it just exceeds 10. This is the first in the sequence that exceeds 10, and I will add up these rewards for category 1. This is an overestimate for category 1. Similarly, I'll find category 2 remaining elements, maybe that is 14. Then I will find out B6 may be requiring 8, B7 may be requiring 4, and B5 may be requiring 10. Now I can take the reward, sum of the rewards of all these three. Similarly for category 3. Have you got up to here? Then I will show you how to make an improvement. Has everybody understood up to this point?
Sir,
Right.
rewards meaning, can you explain once more? Rewards, one means
B7 has a requirement of 7 units of land, and B7 will say, I will give you 25 units of reward. B5 will require 4 units of land and maybe give you 10 units of reward. Okay.
yes, sir.
So then, sir, we are dividing those and then multiplying by L1 correspondingly.
We have one by one. We have taken 7. We have, which are we dividing by whom?
So 25 by 7.
Yeah, but that 25 by 7, 10 by 4, all that we use for what?
For sorting.
For sorting. We use that for sorting. Yes, you're right. We have used that for sorting. Got it?
Sir, I got it, but after that, how are we proceeding? I didn't get it.
You're not thinking. You're being spoon-fed now. That is the problem. Just working like class 2, 3, 4 kg people being spoon-fed. If I next time I won't do it. So now let me start explaining like class kg that I have remaining L1. So I have now found that the highest density is B7. So I choose 7 units of B7, of which I get 25 units of reward. Then I choose 4 units of B5, for which I get 10 units of reward. Therefore, my overestimate is 25 plus 10 equal to 35 units. Is it okay now? Still not okay?
Okay, yes, sir. Got it, sir.
For L2, I had 14 and I found B6 to have 8 units requirement, giving maybe 40 units of reward. B7 requiring 4 units, maybe giving 16 units of reward. B5 requiring 10 units, maybe giving 10 units of reward. So the total reward here is how much? How much?
66.
Similarly for L3, whatever. This is how I have calculated overestimate for remaining land L1, remaining land L2, and remaining land L3. Anybody has a doubt? If you'll take so much time, I won't have time to discuss the second question anyway. Anyway, you all will do it yourselves.
Excuse me, sir.
Yes.
Sir, why don't we only add the rewards until it doesn't exceeds the L1? Like,
Okay. So let me show you why we don't add the rewards. Because you all did not even think about the last assignment that we did. Maybe you all are not getting time to study. So let L1 equal to 10 and let B7 equal to 7, B5 equal to 4, and B8 equal to 6. Okay. let the return of this fellow be 7, let the return of this fellow be 4, and let the return of this fellow be 6. All right. All right, or not?
Yes, sir.
So by your method, you would choose only 7.
Yes, sir.
But as you can see, 10 is possible.
Okay, got it. Got it, sir. Got my mistake.
Anybody else has a doubt?
Sir, can we include it here the number of employees also? Because in some
That we
cases,
will need to improve. We have not even understood this. We have spent half an hour trying to understand this much, which is a standard knapsack problem. Now we will come to employees. We are still not got the best heuristic yet. We still need to get the best heuristic. We have still not got the best heuristic yet. Listen to me very carefully. I think you are not studying, maybe not getting time to study, but or got used to not studying except before the exams. So let us look at this case where I said L1 was remaining 10. 7 had 75, 25, 4 had 10. So obviously I will choose 7 units and get a reward of 25. Now how many are remaining out of 10 then? How many are remaining out of 10?
3, sir.
3 units.
And if I choose 4, I get 10 units of reward. But because I'm finding a heuristic estimate, nobody is telling me that I have to take 4. I'm just finding an estimate. So what I will do is I will find 3/4 of 10 and say at least 7.5 more units of reward will be obtained as an overestimate. That means instead of taking the last element fully which overshoots, I only take the fractional amount of that last element. Multiply it by the weight density, that is 10 by 4. Because only 3 units are left and I have to take 4 and it overshoots. So I will take the weight density 10 by 4 and multiply by 3 to get 7.5 and say that my overestimate HN for first category, category 1, is 10 plus 7.5. And I will prove that this is an overestimate.
25 plus 7.5.
Sorry, 25 plus 7.5. 25, sorry, thank you. And say this is my overestimate. Instead of choosing 35, I will say 32.5 is an overestimate. And because it is close, an overestimate is more accurate if it is smaller. So this will be a more accurate overestimate for H1, for the first category. Clear? Is it clear?
Yes, sir.
Now, come and see this case which you just pointed out to me. Here, by this, I would have got either 7 or 11 or 13 or something like that. But now I will get 7 plus 3 into 4 by 4, which is equal to 10. It's an overestimate. At least it is as much as I can get or more, but it will be accurate. So this is how I calculate my HN value, and then I use Fn equal to Gn plus Hn, and in my algorithm A star, which node do I remove from open?
The smallest Fn.
That is for minimization problems, no?
So it's the largest Fn. Largest.
The maximum f of n.
Right. So remove from open. Read all this carefully. You'll have a test next week. The node with largest Fn. Very good. We have still not done how to find a goal test. That you all do by yourselves. I will not do. Problem number 2. Move on to problem number 2. Sorashish, are you there?
Yes, sir. Yes, sir. Yes, sir.
We can extend their submission time today. Let them write everything and they can submit by 7 o'clock or 7:15. Because we are discussing, we are spending time discussing, they are not getting time to write the answer. Okay?
Okay, okay.
So move on to question number 2. All of you move on to problem number 2. And do part A. Do part A for problem number 2. Anybody who solves it may just take a snapshot of it and paste it in the chat box. Anybody who has solved 2A, paste it in the chat box.
Okay.
Asking for the ones that will be.
I can't hear you. Tell me again.
So are you asking for the values that will be pruned?
No, just look at the draw the tree and mark what will be the values and where pruning will occur. Mark where pruning will occur. Like Kshitij Anand has pointed out. Is this the tree I gave you? Yes. Good. So Kshitij Anand has given a solution. Kshitij, why did you delete the full right branch from 53 at that min node?
Sir, am I audible?
Yes.
Sir, so after the 20th step, I am getting 53 at the min node. And after the 13th step, my tentative value at the root node, which is a maximizer node, is 12.
Yes.
Now, when I arrive at the first like child level of the root node, so 53 is on a minimizer node. So let's say I get something. Okay.
You cannot delete that right side without looking at anything. You cannot delete the right side. You check it, you will have to go down to 71.
Yes, sir. 71 will come.
71 will come, then the right branch will get deleted. The right branch will get deleted there, Hana?
Yes, sir.
And then you will go up and then.
Yes, sir.
I'm seeing others, I'm seeing. Ayush Sharma. Wait, let me see this done this way.
Sir, in that, sir, my solution, I have not pruned the 5. Like, sir, that is incorrect. What I have shown.
Correct. Good. You are getting the hang of. So, good.
Hello, sir.
Nikhil, let me look at Nikhil.
Sir, why is the 5 getting pruned?
5 in which one?
In the first solution sent on the chat.
In the first solution sent on the chat. Let me go back there and see. Why is the 5 getting pruned?
Oh, yes. So since we don't know the range of values, what if it's less than 1?
Which one?
Instead of 5, what if we have 0 or -1 or something?
No. What has been backed up at the left child? 1, है ना? 1 has been backed up?
Yes, sir.
Now, what is the tentative value at the root? 12.
Okay, sir. Understood.
Got it?
Yes.
Nikhil? G. Lakshmi Nikhil?
Yes, sir.
71's right child will be pruned because at the top, 71's right child is right. Now, 53, no, this is all right. This is all right. Perfect.
Yes.
Perfect. Once you back up 71 at the max node, you prune the right side. Very good. So all of you, we are out of time. You please complete it. And by 7 o'clock, all of you submit in the Google form. All right. All of you, please submit the solutions in the Google Sheet by 7 o'clock. Ritaman, your solution is right. Ritaman?
Yes, sir.
Your solution is correct.
Yeah, thank you, sir. Yeah.
So all of you, I am signing off now. I hope this session was useful.
Yes, sir.